There are 3 skills you need in 4.10. The first one is you need to write a quadratic function in vertex form. Write a quadratic function in vertex form. So for a question like this, they're going to give you the vertex, and they're going to give you 1 point. So the vertex will be 1, -2 maybe, and the point will just be some point on the graph, like 3, 2. So let's go ahead and graph this. We don't even need to we can't plug this into our calculator actually, we just have to draw it. The vertex is at 1, -2, so 1, -2. And a point on the graph is 3, 2. 1, 2, 3. So we know it looks like this. It has to open up. It can't open down or else it wouldn't pass through that point. And vertex form is this. It's y equals a times x minus h squared plus k. That's the vertex form. So the vertex is h, comma k. It's very important. The vertex is h, comma k. So we're going to plug that in. Y equals a times x minus h. That's 1 squared minus 2. The plus k, we would put in plus minus 2, but we can just say minus 2. But really what we mean is plus minus 2, right? Then what we're going to do is plug in that 1 point that we already know. The point being 3, 2. So that's 2 equals a. 3 minus 1 squared minus 2. We have to simplify this, so 2 equals a. That's 2 squared is 4, so a times 4 minus 2. Add the 2. A times 4, divide by 4. And a is equal to 1. Now, we can write out the equation in vertex form, which is y equals 1. We know that a is 1, so we can put that in right here. Times, we get the same color here, 1 times x minus 1 squared minus 2. So the answer is y equals x minus 1 squared minus 2. So basically, most of the problem is done for us in this step. We just plug in that point to find the a. We plug in that point to x and y to find the a. That's the only thing we're missing. Once we plug in a, we leave it in that form. Y equals x minus 1 squared minus 2. And that's our answer for the first part. The second type of problem is to write a quadratic function in intercept form. And intercept form is y equals a times x minus p and x minus q. And it's called intercept form because it's factored out. If we set those equal to 0, we could find the x-intercepts really easily because it's already factored out. So for a problem like this, it's going to tell us the x-intercepts. So maybe it'll say x-intercepts are -1 and 4, and it will tell us a point, which is 3, 2. So let's plug those x-intercepts in to -1 and 4. And we have 1 point, 3, 2. So we know it's going to look something like this. Now, we're going to use this equation to find the answer. Remember, we're looking for a. We have almost everything else. We just need to look for a. So we get y equals a times x minus p. P is just one of those intercepts, so whatever. X minus the negative 1, we'll just start there, times x minus q, so x minus 4. Simplify, clean this up a bit. A times x plus 1 times x minus 4. Then we're going to plug in that point to x and y. So I'll grab a different color so you know what I'm talking about. So we have the point 2 equals a times, we plug in that for the point to x, 3 and 3. Keep everything else the same. So 3 plus 1, 3 minus 4, and I just plug in that point 3 too. Notice I had to plug in the x twice. I had to plug it in here and here. So we're going to solve for a. So we have 2 equals a times, that's 4, times negative 1. So we're going to have negative 4a equals 2, divided by negative 4, so we get negative 1/2 equals a. And then we're just going to write the equation back out, just substituting this in for a. So we have y equals negative 1/2 times x plus 1 and x minus 4. So notice in the final answer we don't use that point, we just use the x-intercepts. But we also have a, so we can write that as well. This is the final answer for this one. The last type of question, the third type, is write a quadratic function in standard form that passes through 3 points. So this one, they don't give you the vertex, they don't give you the x-intercepts, they just give you 3 points. And you have to figure it out. So my example is, they say this function, this quadratic function, passes through negative 1, negative 3, 0, comma, negative 4, and 2, comma, 6. Now we could graph that out and put those points, but I think you know where those are. So in order to do this, it actually is pretty difficult. It'll take a while, so please follow along closely. You may want to follow along with your calculator and with a piece of paper as well. This is basically the same as solving a system of equation with 3 variables. We have to write 3 different equations. So the first one, the first equation is y equals ax squared plus bx plus c. And we're going to plug in that first point to x and y. So negative 3 equals a times negative 1 squared plus b times negative 1 plus c. So we get negative 3 equals negative 1 squared is 1, so a minus b plus c. This is the first equation. Okay, we have to do this again with the second point. And we're going to get negative 4 equals a times 0 squared plus b times 0 plus c. So we're going to get negative 4 equals, okay, that's 0 plus 0 equals c. Because a times 0 is 0, b times 0 is also 0. So this is our second equation. And we need to do this for the last one. And let's need a different color for this. Orange. So the third equation is 6 equals a times 2 squared plus b times 2 plus c. So we get 6 equals 4a plus 2b plus c. Now I'm going to clean this up a bit. I'm going to erase what I did and just stack these up, but of course on your paper you have more space than me. So once again, my 3 equations are a minus b plus c equals negative 3, c equals negative 4, and 4a plus 2b plus c equals 6. Now, you need to solve for a, b, and c. So we can write it back into the form y equals ax squared plus bx plus c. However, you get to choose how you want to do this. I think everyone was pretty successful with Cramer's rule, so I'm gonna go ahead and use that. Of course, you can solve by substitution or elimination. That's always an option. I like Cramer's rule though, so let's go ahead and write those two matrices. So we have 1, 0, 4, negative 1, 0, 2, 1, 1, 1, and we have negative 3, negative 4, positive 6. Sorry, that's a positive 6. And of course, you're going to define the determinant of this. That's the original one, which I've already done. Is the determinant of that is equal to 6, or sorry, negative 6. Keep messing up the negatives and positives right now. But the determinant is negative 6. And then once you find that, of course, you're just going to swap in this for whichever variable you're looking for. Are you looking for the A? Are you looking for B? Are you looking for C? You're going to swap it in and then divide it by the determinants. Remember, if you're looking for A, you're going to do the determinant of negative 3, negative 4, 6, negative 1, 0, 2, 1, 1, 1, because I swapped it in for A, divided by negative 6. That's going to generate your answer, which is 2. You're, of course, going to do this for the other ones, too. So B equals 1, 0, 4. Okay, the determinant of that, of course, negative 1, 0, 2. Sorry, we need to swap in this for B. So negative 3, negative 4, and 6. 1, 1, 1. Divided by negative 6. And that answer will give us 1. And if you don't remember how to do this, you have to go back and look at 3.7, because in 3.7 I walk you through how to solve these types of problems using Cramer's rule. Last one is we need to solve for C, and I'm just so out of space, I'm just going to do it up here. So of course that's the determinant of 1, negative 3, 0, 0, negative 4, 4, 2, 6, divided by negative 6, and that's going to give us negative 4. So our answer then, the actual answer to this question, is y equals 2x squared plus bx, b is 1, so just plus x, minus 4.